Very good. Suppose we have a polynomial. Our job is to analyze polynomials today. Suppose we have a polynomial and we are interested in finding the zeros of the polynomial. There you go. Example says, find the zeros of the first one is easy one. Here you have x squared minus 1. The second one, we are making it a little bit more interesting. We have negative 2x to the 4th plus 2x squared. Okay, very well. So how do I find zeros? What is the definition of a zero? We call that zeros are the x values when the graph hits or intersect with a x-axis. X-axis. We saw another definition for zeros before. Remember x-intercepts? So you're actually finding the x-intercepts. Zeros and x-intercepts are the same thing. So how do I find a zero for the first one? To find the zero, we set y equal to 0 and solve for x. So let us do that. My y is f of x. This guy is 0. So we have 0 equals to x squared minus 1. To solve this equation, this is an equation. To solve this equation, we have two options. So, two options. The first option is just add 1 to both sides. You get x squared equals to 1. Take square root of both sides. You get square root of x squared equals to square root of 1. On the left-hand side, you end up with absolute value of x equals to 1. So x is plus minus 1. This is your first choice, first option in solving x squared minus 1 equal to 0. The second choice is use factoring. So how do I use factoring? What is this guy? Recall that in algebra, we have the difference of squares. The difference of squares, if I have x squared minus y squared, this guy can be written in factored form, x minus y times x plus y. Guys, this is not the same as x squared minus y squared is not the same as x minus y squared. This is a different story. So, what does it call? It's called the difference of squares, x squared minus y squared, which can be written as the multiplication of two linear expressions, x minus y times x plus y. Common mistake, x squared minus y squared is not the same as x minus y to the second power. So let us identify. Here I have x squared minus 1. I can write x squared minus 1 as x squared minus 1 squared. I have x squared minus 1 squared. Can be written as the factor form, x minus 1 times x plus 1. Well, I wrote this guy in factored form. I set it equal to 0. What's the meaning of that? It means that either x minus 1 is 0 or x plus 1 is 0. Solve each of them. X minus 1 is 0. It means that x is 1. X plus 1 is 0. It means that x is minus 1. We found 2 zeros for this function. What's the meaning of that? It means that the graph hits x-axis at 2 points. Use either the first method or use factoring. It doesn't matter. The answers must be the same. Let's check Desmos.
Professor, can you go back to the other screen?
So let's take a look at our Desmos. Here we have x squared minus 1. X squared minus 1. Well, take a look at your parabola. Guys, we have a quadratic function. We have a parabola. Look at x-intercepts. One of them is x equals to 1, and the second one is x equals to minus 1. Always check the graph. After you do the algebra, make sure your graph matches the algebra that you did. The algebra shows, well, x is plus minus 1. I have 2 zeros. I just checked Desmos. It verified that my answers are correct. We have 2 zeros, x equals to 1 and x equals to minus 1. So I'm done with part A. Let us move on to part B. Make it interesting. We are learning new things. We are interested in having more complicated questions. The same process. To find zeros, we set y equal to 0 and solve for x. So set g of x equal to 0. I have negative 2 x to the 4th plus 2 x squared. To solve this guy, you have to start by factoring. Start by factoring. From algebra, so this is algebra part. We can factor out negative 2x squared. So minus 0 is on the left-hand side, minus 2x squared is factored from the first term. So you're left with x to the second. Minus, if I factor out minus 2x squared out of positive 2x squared, I left with a negative 1. So again, remember that. Let me write this here for you. These are good recalls from algebra. From algebra, we know that. Recall. From algebra, we know that negative 2x to the 4th is negative 2x squared times x squared. Remember that if you have x to the n times x to the m, you write one base and add the exponents, all from algebra. So negative 2x to the 4th can be written as negative 2, x to the 4th is x squared times x squared. Well, so when I factor out negative 2x out of negative 2x to the fourth, I'm taking away negative 2x squared. What's left? X squared is left. Now, 2x squared can be written as minus 2x squared. So this 2 can be written as minus 2. So when I factor out negative 2x squared, I'm taking away negative 2x squared. What's left? Negative is left. What's the meaning of negative? Negative means negative 1. So this is negative 1 times negative 2 times x squared. That's how we end up with this negative 1 inside parentheses. Very well. So let me rewrite this guy for you. So if you have negative 2x to the fourth plus 2x squared, you can factor out negative 2x squared. You're left with x squared minus 1. That's the reason behind it. Okay. So we're setting the multiplication equal to 0. What's the meaning of that? It means that either this term is 0 or this expression is 0. So set negative 2x squared equal to 0. Negative 2x squared is 0. What's the meaning of that? It means that the only option is x to be 0. X is 0. X squared minus 1 is equal to 0. We already solved that here. We don't have to go through it again. We already know when we are solving x squared minus 1 equal to 0, x is plus minus 1. So how many zeros do we have? 1, 2, 3. This function has 3 zeros. This function has 3 zeros. Can I check this? Of course. You can plug this back into the function and check to see the y becomes 0 or not. You can also use Desmos to graph this function and see the intersections with the horizontal line with the x-axis. Let us take a look at Desmos, then we go back to the board. So here we have negative 2x to the fourth plus 2x squared. Well, check out this graph. How many intersections do we have? 1 is here. Negative 1, my x is negative 1. The other one is at the origin. My x is 0. And finally, I have negative 1, positive 1, and 0 as 3 points of intersection with x-axis, x-intercepts, or the zeros of the function. Let us take a look at Desmos for this example. Here we have x to the fifth minus x. Guys, take a look at the graph. Here you have 1, 0. You have another 0. You have your next 0 right here. We expect to have 3 zeros for this function. At 3 points, the graph hits x-axis. Let us do it algebraically. So our example here says x to the fifth minus x equal to 0. There we go. find the zeros of x to the fifth. Let's call it, for example, h of x, x to the fifth minus x. So to find zeros, set h of x or y equal to 0. So you get x to the fifth minus x equal to 0. Well, to solve this, it's a common mistake. Students do this. Guys, this is a no-no. Let me use a bold color like red. It's a no-no. Students tend to write it this way and get just 1, 0. They write it as x to the fifth is equal to x. And then, hey, if I solve this, I get x to the fourth equals to 1, and then x is equal to 1. It's wrong. You cannot write it this way. No, no. You have to start by doing some algebra, start factoring. Algebra, factoring. Well, okay. How do I factor out? I can factor out x. What's left? X to the fourth is left, minus, if I factor out x from this expression, I left with 1 equal to 0. So how many options do I have? I have to set x equal to 0, and I also have to take this expression and set it equal to 0. So x is 0, x to the fourth minus 1, 0. You have to deal with these two separately. X is 0, which is 0. We found the first 0. This is our first 0. Now set x to the fourth minus 1 equal to 0. Okay. For this guy, you have 2 options. So you can either write it this way. Add 1 to both sides. X to the fourth is equal to 1. Take the fourth root of both sides. Now take, guys, it is not square root. It's the fourth root of both sides. So the fourth root of x to the fourth, the fourth root of x to the fourth is equal to the fourth root of 1. The fourth root of x to the fourth is absolute value of x, and the fourth root of 1 is always 1. So x becomes plus minus 1. This is our first 0. We found 2 more zeros. So in general, we have 3 zeros. Again, you can either solve it this way, or you can use factoring here. This guy, factor out this way. X to the fourth minus 1 can be written this way. Going back to algebra, recall. X to the fourth is x to the second raised to the second power. So if you have x to the fourth minus 1, you can write it as x squared to the second power minus 1 to the second power. You have the difference of 2 squares. The difference of 2 squares, which is, remember that, if you have a squared minus b squared, this is a minus b times a plus b. So you get x squared minus 1 times x squared plus 1. So this guy can be written as x squared minus 1 times x squared plus 1 equal to 0. Again, This means that either x squared minus 1 is equal to 0 or x squared plus 1 is equal to 0. So set this guy equal to 0, then set x squared plus 1 equal to 0. However, if you set x squared plus 1 equal to 0, you get x squared equals to -1, and you get x equals to square root of -1, which is I, complex identity, which is not a real number. So ignore this. You get x squared minus 1 equal to 0, x is plus minus 1. So for this function, we have 3 zeros. As we saw in Desmos, this function has 3 real zeros. In general, if we have something like this, if we have an exponent like n, exponent n, for a variable like x, if you have x to the n equals to a number, any number, like a, to solve this, we can take the nth root of your left-hand side to cancel out the exponent, which is n. We take the nth root of both sides. This is the general method we're using when we have x to the n equals to a number, not a variable. You have a variable to exponent n, and on the right-hand side, you have a constant, you have a number. So in general, you take the nth root of both sides. The nth root of left-hand side is equal to the nth root of right-hand side. The nth root of left-hand side is x to the n. On the right-hand side, you have the nth root of a. If n is even, you end up with absolute value. So now you can divide this up into 2 cases. If n is even, we get absolute value of x equals to the nth root of a, or x is plus minus the nth root of a. But if n is odd, if n is odd, then we have x equals to the nth root of a. These are the algebra rules that we apply when we are solving equations like this. We have different classifications when we are solving equations. If you have x to the n equals to a number, to get rid of this exponent, you take the nth root, this is the nth root of both sides to cancel out n and n, the index and the exponent. They are, in some sense, are opposite operator. If n is even, like 4, like 2, like 6, like 8, you get plus minus 2 answers. Why is that? Because if this is raised to the even exponent, then plus and minus, they consider to be just plus. You're raising them to an even exponent. So your final answer has plus minus in front of it, 2 answers. But if n is odd, then you get just 1 answer. Before we introduce complex numbers, just a quick note. If we have something like this, suppose I give you an equation of this form, and I ask you to solve it. Just a quick note. If I ask you to solve, for example, x to the 4th minus x squared equal to 0, and you say that, hey, I'm going to factor out x squared times x squared minus 1 is equal to 0. So here we have two options, am I right? The first option is to set x squared equal to 0, and the second option, where's my marker, is to set x squared minus 1 equal to 0 and solve for each of them. You can generally write it in factor form as x squared times x minus 1 times x plus 1 equal to 0. So this is called the factored form of this equation. Write it in factor form. So just a quick note. When you're setting x squared equal to 0, x squared equal to 0, it means that x times x is 0. It means that x is 0, but this 0 is repeated twice. We say that 0, just this 0, 0 has multiplicity 2, because it's repeated twice. It is repeated twice. This is the note that we want to mention. As long as you see exponent 2, exponent 3, exponent 4, then you say that, hey, the multiplicity is 2, the multiplicity is 3, the multiplicity is 4, and so on.